This problem requires the understanding of principle of conservation of energy, momentum, and the impulse. Let me explain what this problem is. You have an object. This is an object here, and this object is at certain height from the ground. Let's say this is the ground. The mass of this object is 2.5 kilogram, and this mass is at a height h, which is given 3.75 meter. What you need to calculate now, if you let this mass drop, what is the impulse it imparts to the ground? So the impulse is basically the change in the momentum. Impulse is change in momentum is equal to change in momentum. So in order to calculate momentum, you need to know the mass and the velocity. The velocity at this point is 0 because this object is at rest right at this point. We call this point at A, and at B this potential energy is converted to the kinetic energy at point B. So we need to find out what is the velocity at this point B. So there are different ways of calculating the velocity. What I'm doing here, the potential energy at that point A is exactly equal to the kinetic energy at point B. So from conservation of energy, the potential energy at point A is equal to kinetic energy at point B. What is the potential energy at this point? The potential energy at this point is equal to mgh, and the kinetic energy at this point is equal to half mass times velocity squared. This mass cancels out, and the velocity can be expressed as a square root of 2gh, and s is the height here, and you just need to plug in all the numbers here. The number two, the gravity is 9.8, and the height is 3.75. Once you plug in all the numbers, then you will get the velocity to be 8.57. This velocity is 8.57 meter per second. So the next step is now to calculate the impulse. How do you calculate the impulse? As I mentioned before, the impulse is equal to the change in the linear momentum. So let me write down here. So the impulse equal to change in the linear momentum. The delta sign here means the change in the moment change, and this is the momentum. So this is equal to the change in momentum, and the momentum at point B. So I'm just writing the linear momentum at point B minus linear momentum at point A. Momentum at A. What is the momentum at point B? It is equal to the mass times velocity. At this point, the momentum is 0 because the velocity at point A is equal to the 0. What is the mass? The mass is 2.5 and the velocity is 8.57. Once you plug in all the numbers, the answer you will get is 21.4 Newton second. The other unit it can have is kilogram meter per second square. This is the mass. This should be the meter per second. This should be the meter per second. So you can use either of the Newton units.